After removing these small pieces from our fracture geometry, we need to update the constraints and remove any constraints that were attached to pieces that no longer exist. So I'll drop in a null node for our constraints and name it as such, call it constraints, and we'll connect the second output from our RBD unpack to that. Now to loop over each constraint and check it to see if it's valid, we're going to use a for each primitive. We're not using for each name primitive because we're not looping over sections of geometry based on an attribute. We're just looping over each individual constraint primitive line. So if you display the for each begin, you can see there's just one tiny little constraint line up there that's been selected. I'll zoom in on that. And each constraint line has 2 points, point 0 and point 1, and each of those points contains the name of the fracture piece that it's connected to. So we can look up in our fracture geometry if these names exist there, and if either of them no longer exist in our fracture, then we can delete that primitive. So to check each constraint, I'll create a primitive wrangle. I'll drop that in the loop, and we can call this check constraints. And we'll need to connect our fracture geometry to the second input of that wrangle in order to check the name attribute on the fractured pieces. Now in this wrangle node, I'm going to paste in a bit of vex here. And what this vex does is it'll check the name attribute on point 0 and point 1 of the current constraint line. And then it will look up from input 1, that's the fracture geometry, to see how many instances of each name it finds in our fractured geo. So it'll store the number of name A's that have been found and the number of name B's that have been found. And if either of those are 0, then we want to remove the constraint primitive. So one way to determine if either of them are equal to 0 is to just multiply them together. So that's why I'm checking if num A times num B is equal to 0, then ultimately we will remove that primitive. So if we display that for each end and let this process for a minute, then that will give us our updated constraints. So it's not very obvious visually that it's fixed all of our constraints to remove the no longer needed ones. But if you middle mouse on that for each end, you'll see we now have 66,000 polys in that constraint network. And on our original constraint network, we had 186,000. So that's reduced the number of constraints by a pretty massive number. And now that we have our constraints optimized a bit, we can once again do an RBD pack, and we'll connect our optimized fracture to the first input and our updated constraints to the second. Now we've finished these optimizations for our building, but before we cache out our packed up asset, we're going to generate some proxy geometry via convex decompose, which we'll look at in the next video.